Hi, I'm Wei from 2B24 from the group Yawns. I'll be talking about section A today. What is numerical integration? Why do we need it? When do we apply? What is trapezoidal rule? Application and constraint, and its advantages and disadvantages. For the first part, we are talking about what is numerical integration. It's basically to find an approximate value of the area under the curve. This is one of the curve y equal to fx, and the shaded part is the area.
Now, let us move on to trapezoidal rule. What is trapezoidal rule? It is simply a rule to calculate the approximate value of the area under the curve. Below show a diagram of a graph. This is a curve y equal to fx, integrating from a to b, and the shaded part over here is the area under the curve. Area under the curve is equal to How do we apply the trapezoidal rule? Now let us recall back what is trapezium. This is one of the shape of trapezium. And the area of the trapezium is half times sum of the parallel sides times the height. Therefore, the area of this trapezium is equal to half times a plus b times its height.
How do we do question using trapezoidal rule? Here is a curve y equal to fx. Integrating from a to b. For the first step, you need to find the number of strips divided, which is n. y0 is the first n, y1 is the second n, y2 is the third n, and so on. For the second step, we need to find the width h, where h is equal to b minus a over the number of strips, which is n. And finally, to find the area here, which is half equal to sum of parallel sides and its height. So it is half times y0 plus y1 times h. Therefore, we derive a formula like this. Half bracket y1 plus y2 bracket h is the area under here. And after we simplify it, we will get a formula like this. Let's take a look at example 1 on page 25. The question is, evaluate square root 1 minus x cubed integrating from 0 to 1 using the trapezoidal rule into 4 strips. Firstly, the number of strips is given 4. Next, to find the width, we use b minus a over the number of strips and we'll get 1 over 4, which is 0.25. Next, we construct a table where x is increasing by 0.25. And to find the value of square root 1 minus x cubed, we need to sub x into x equals 0 into square root 1 minus x cubed, and therefore we'll get 1. Next, we sub x equal to 0.25 and square root 1 minus x cubed is equal to 0.992, and we'll get the value over here. Next, we continue to do that, and finally we derive a table over here where y0 equal to 1, 0.992 equal to y1, and so on. Lastly, by using trapezoidal rule, square root 1 minus x cubed integrating from 0 to 1 is equal to h over 2 bracket y0 plus y4 plus 2 bracket y1 plus y2 plus y3 bracket and close bracket, and we'll get 0.797 as an answer. Let's take a look at tutorial 4 question 1. The question is estimate bracket 1 plus x squared bracket to a power of 3 over 2, integrating from 0 to 3 by the trapezoidal rule, where n is given 6. For the first step, given n equal to 6. For the second step, we find a width which is h, and we'll get half. Next, construct a table with x increasing by half. To find a value over here, sub x equals 0 into bracket 1 plus x squared bracket to a power of 3 over 2. And to get a value over here, sub x equal to half into bracket 1 plus x squared bracket to a power of 3 over 2, and so on. And we name 1 as y0, name 1.40 as y1, 2.83 as y2, and so on. By using trapezoidal rule, bracket 1 plus x squared bracket to a power of 3 over 2, integrating from 0 to 3 is given as this formula. And after we sub all the value in, we will get 28.545 as the answer. Lastly, the advantage of using trapezoidal rule is that there can be any number of data points. For these advantages, the error only reduces proportionally to the data spacing and requires a lot of calculation and is easier to make mistakes.